What kind of symmetry do the following curves have? So this is the polar equations. Here is a method of checking symmetries. For the polar axis means basically x-axis. If theta is changed to negative theta and the equation remain unchanged. Let's try that. So to check polar axis, if I change theta to negative theta, so the equation would look like 8 sine negative theta r equal to, but when sine is an odd function, that is negative sine theta, and that is not same as the original equation. So for the polar, no symmetry, not symmetric with respect to polar equation, right? Let's check with the pole. To check with the pole, we need to change either r to negative r or theta to theta plus pi. So let's try theta to theta plus pi. So r equal to 8 sine theta plus pi. Now theta plus pi is in the third quadrant, sine is negative in the third quadrant. So that also is gonna be negative sine theta. Again, not same as the original equation. So not symmetric with respect to pole also. Okay. Lastly, to check with y-axis, you need to change theta to pi minus theta and see if the equation unchanged. So theta to pi minus theta in the original equation, r is equal to 8 sine pi minus theta. Pi minus theta is come to the second quadrant. In second quadrant, sine is positive. So that has to be 8 sine theta, same. The equation stays same as the original equation even after changing theta to pi minus theta. So we're gonna say the given curve is symmetric with respect to theta equal to pi by 2 line, or you can simply say y-axis because that is the vertical line. Okay, you can also just look at the graph of the equation. So if I graph the equation, let's clear this one. It's 8 sine theta. Graph is, I need to zoom out. This thing, right? That's a circle with center on y-axis, and you can notice that it is symmetric with respect to y-axis. So our work is justified with the graph also. Here is another example of checking the symmetry. Let's try one at a time. The first one is polar axis. Change theta to negative theta. See, the equation doesn't change. R is equal to 2 cosine 4 times negative theta. That's cosine negative 4 theta. Cosine is an even function that stays same at negative. So it's the same equation as the original one, right? Therefore, we have yes, symmetric with respect to polar axis. Let's try the same equation with respect to pole, which is origin. To do that, you need to change theta to pi plus theta. So r is equal to 2 cosine 4 times pi plus theta. That's 2 cosine 4 pi plus 4 theta. So basically what's happening is cosine is periodic with 2 pi, right? You are adding a multiple of 2 pi. This is 2 times 2 pi. So taking 2 revolutions and coming back. And that is same as 2 cosine 4 theta. And that gives you back the same equation. Therefore, we have symmetry with respect to pole also. That is also available to us. Let's try the last one. Symmetry with respect to theta equal to pi by 2 or y-axis. To check with that, you need to change theta to pi minus theta. So let's try that. R 2 cosine 4 times pi minus theta. That is 2 cosine 4 pi minus 4 theta. Because 4 pi added to this should be same as negative 4 theta, because 4 pi is 2 revolution and cosine is periodic with 2 pi. And cosine is even, therefore that should be same as 2 cosine 4 theta. So we get back the same equation, therefore we have symmetry with respect to y-axis also. So this graph is fun. This is symmetric with respect to polar axis, which is basically same as x-axis. This is symmetric with respect to pole, which is same as origin. And this is symmetric with respect to theta equal to pi by 2, which is same as y-axis. So let's see the graph of this. The graph is 2 cosine 4 theta. Oh, you see that's a pretty graph, and it is symmetric. Diagonally, it is symmetric with respect to x-axis. It is symmetric with respect to y-axis. Symmetric with respect to all three things.